session is Professor Aleksandar Andjelkovic, a dear friend. He is a researcher and consultant focusing on IEQ, HVAC systems, energy efficiency, building design, performance and operation, renewable energy audits and management, district heating and cooling systems. Active in ASHRAE, RIVA, IBIPSA and Serbia National HVAC Society. Published more than 100 papers, articles and made more than 150 presentations on IEQ, HVAC energy efficiency, sustainability and renewable energy throughout the world. Thank you.
Thank you, Dimitris. Good afternoon to everybody. It is a really great pleasure for me to be here today with you. First of all, I would like to thank you, Dimitris, also Kostas, and all of the people from Hellenic chapter for inviting me. So it's always a privilege, and always I'm very happy when I'm with my big friends. So we had a great cooperation and great communication. So Greece is a great friendly country for me. The presentation for today is much more similar to what was done last year. I excuse to my colleagues who listened to me last year. The reason for that is because currently we are under developing the device, which we will be talking about later. And currently we are adapting to the new standards regarding the indoor environmental quality. So this is the agenda for today. After the introduction, I will talk a little bit about the current standards related to the indoor air quality. And after that, I will talk about the development of the device, which is development under our department of University of Novi Sad. The device is called ENVIRA, and it's a device relating to the measuring and monitoring of the indoor environmental quality. And after that, I will talk a little bit about the case studies related to the ENVIRA platform, and of course, at the end I will talk about some conclusions and the future developments of the platform. So, regarding the introduction, as you know, in Europe, roughly we have more than 24 billion of square meters area, which represents roughly 74% of residential area. About 186 residentials are permanently inhabited, and only 11% of these existing buildings is under some level of renovation. What is also important to say is that about 85% of existing EU buildings were built before 2000, and 75% of them has really poor energy performance. And what is also of great importance is that more than 85% will be still in place after the 2050. When we talk about the standards, we have ASHRAE standards, and also we have European directive for energy conform buildings. So definitions of the accessible indoor air quality is pretty much similar in these standards. And what is the important regarding the European part is that we will have to have the indoor air quality monitoring devices in new zero emission buildings, which is good information, because with this monitoring device we will have the information for the future development of the standard and protocols regarding this part. These are the figures which highlights how to say the people and the humans in the indoor. It's called the building code. So more than 85% of the time we spend in the buildings. Around 79 years, it's the average lifetime for the male in EU. And practically 69 years we spent in the buildings. 54 years at home, 26 years sleeping, about 4 years we commute, and only 6 years we are outdoor. So regarding that, and also the needs for the air for the living, we inhalate roughly 13 kilograms of air daily, much more than we eat. So these are the figures which highlights the importance of the air quality and also indoor environmental quality at home. So the buildings, when we talk about buildings, firstly we, how to say, maybe decade and a half or 2 decades, we only talk about the energy efficiency measures, but the first point of the buildings are the people. So buildings are made for the people, and buildings should work for the people. So we must follow all the principles regarding the sustainability principles about during design and also operation and maintenance regarding the people, not just energy efficiency. Of course, buildings must ensure that do not create the risks for the health and promote health and healthy behaviors of occupants. And of course, buildings must be climate neutral. Regarding the indoor environmental quality definition, in the first stage of investigation and research, we just followed only one part of the comfort. It was the thermal comfort. Aleksandar was the one of the most important and most famous researchers and professors in that field. And after we to the thermal comfort, we add other categories like firstly indoor air quality, after acoustics, and of course light. So practically indoor environmental quality is quality for the indoor environmental quality for all of these 4 categories. So the thermal comfort, indoor air quality, light, and acoustics. What are the main effects of the indoor environmental quality? Practically reduced comfort and well-being, reduced quality of the life, increased prevalence of acute non-clinical health symptoms, also reduce, what is also one of the most important things, reduce the work performance. As you can see on these graphs, increase absenteeism, reduce learning of the children, about 10 to 15%, and of course, disrupt the sleep. So after a poor sleep, we have reduced health and other cognitive performance. So usually people think about wealth and well-being only just after they got some issues related to the health. But people, when experience some financial problems, they usually act immediately. So on this slide you can see some share about percentage of economic implications regarding to the indoor environmental quality. So practically in the one example of the office building, energy cost is represents only 1%. Other costs are related to the rental or staff and salaries or benefits. So practically only modest gains in the work performance we can deliver very significant financial benefits. So even 1% of increase in that productivity is very cost effective. So this slide is not, how to say, I'm not talking that energy efficiency is not important. It's very important, but we need to think about other things which can bring also benefits regarding the indoor environmental quality. Regarding the standards, we also have some not issues but problems related to the indoor air quality standards. Usually they are not sufficiently ambitious. Usually address needs only for the average person, neglecting the individual and preference and differences. Also, usually they do not address combined effects, and only they are here to have the risk reduction. So the future standards in this area should ensure firstly resilience, flexibility, diversity, preferences, and also monitoring in order to have the better standards in the future. Regarding this, we have a lot of substances which can cause our health issues, and in current research, we firstly need to address, and we must agree to select the pollutants for monitoring. So currently, we are working with the colleagues from the DTU in order to establish the new standard related to the indoor environmental quality. So we are trying to agree and to select what the pollutants should be monitored in order to have adequate standard, which is called tail index. Our colleague Pavel Bregotsky is working on that, and we are supporting him regarding our device. So this is the one of the things that we are working on currently. So we are adapting our device in order to be aligned with this standard. So regarding this device, which are developing more than 5 years on my faculty, firstly, we review all the standards, all the globe. So we have different standards in Europe, US, China, Japan, regarding the thermal comfort and also indoor air quality, acoustics, and light. So firstly, we made a review about the current standards. After, we review on current devices which are available on the market regarding the monitoring of the indoor environmental quality. And based on that, there are only few devices which can use for monitoring and control of the indoor environmental quality. So regarding that, we start to work on our device, which is called Envira. So as you can see, developing on the first, second, and currently final version of the device. We also had a great support from ASHRAE. As you can see the figure here that represents in some way the logo of the ASHRAE. So this is the device that we developed on my faculty, and these are the sensors which are in the device. So you can see on the slide which kind of the sensors we used for the various temperatures, so the globe temperature, dry bubble temperature, also the sensors for the relative humidity, air velocity, carbon dioxide, TVOC, PM2.5, sound pressure, illuminance, and barometric pressure. So we choose these available sensors, and after that, in cooperation with our colleagues from the Switzerland, from EPFL, we mutually calibrate these sensors in order to have accurate results after. So regarding that, we use this laboratory equipment in order to calibrate all of the sensors which are used in our device. After that, after the calibration, we conduct the field case study. So we use 3 buildings. We have first step 2 business buildings with the open plan office, and these are these 2 pictures. And we have additional educational institutions, so the amphitheater of my faculty. So these are the case studies in order to have the first results regarding this device. Besides that, in order to have the methodology, we use also the questionnaire with 15 adequate questions for all people who are in the rooms of these 3 facilities, and with statistical regression, we use that in order to have the indicator for the indoor environmental quality. It's just we use usual linear relationship with weight factors, but the factors for these buildings we obtain with regression analysis of the questionnaire. So regarding that, as you can see here, we have 125 occupants in all field studies, so 69 in the open offices and 56 in educational buildings. So from the regression analysis, we establish and we have the weight factors for the first type of the buildings. So in the first type of the building, so we have the weight factor as a thermal comfort, so 0.35, acoustics 0.285, acoustics 0.195, and illumination 0.17. That was for the office building. And for the educational building, there is a difference because the most important factor was indoor air quality, 0.31, thermal comfort, Indoor air quality and acoustics was equal 0.25. And light was the least important, 0.19. So with these weight factors, the calculated index for the indoor air quality and occupant perception of the results practically were in very good agreement with absolute error less than 3%. So these case studies show us that the methodology and also the device is in very good condition, and we can say with a good precision and good quality of the results. The next step is practically to use this device to adapt and to put it on the cloud. So we will use the Zigbee network in order to have monitoring and also the results, which can be put it on the regular BMS system in the building, and also to use it when necessary to operate HVAC system in the building. And for the conclusions, our next, or how to say, present buildings, healthy buildings, must create healthy environment for the occupants. And also, the one of the most important conclusion is that we must think of clean air as we think of clean water and the fresh food. And with this, we cannot make some or any compromise, or we do not solve with the indoor climate. So thank you. I'm in time probably.